Impedance is the oppositional forces induced by elements within a circuit, of which there is resistance and reactance. But what is reactance? Reactance is defined as the opposition of a circuit element, usually an inductor or a capacitor, to the changing current flow in an AC circuit. For a capacitor denoted by XC, an inductor XL, and is measured in ohms. The inductive reactance can be found by the product of 2 pi, the frequency of the circuit, and the inductance in henries. For capacitors, it is the inverse with capacitance in farads. The total reactance in a series circuit is the difference between the two. The basic principles for a DC circuit can also be applied for AC. So applying Ohm's law to an inductor, we have XL equals Vmax on Imax, and for a capacitor with XC. But let's just go back for a second. AC stands for alternating current, and as the name suggests, it's constantly changing, so we often represent this using sine waves. This is the standard form for the expressions for voltage and current. We represent it in this way because impedance and reactance possess both magnitude and phase, whereas resistance only has magnitude. Its phase angle is 0, as it's a scalar quantity. To see where the equations for calculating reactance come from, for a capacitor's response, we differentiate the current equation where V equals Vmax sine omega t, giving us the equivalent cosine function. This is why the voltage and current equations are out of phase by exactly 90 degrees. Applying these two equations to Ohm's law, we have the following expression. Cancelling out to simplify the expression, we yield the result XC equals 1 on omega c, which can also be written as 1 on 2 pi Fc. The same process can be applied to inductors, yielding this equation. We have just shown that the difference between the sinusoidal waves for current and voltage are 90 degrees, and that they are exactly out of phase. To determine whether the current or voltage wave is leading, we can use the acronym civil. For capacitors, the current leads the voltage. And for inductors, the voltage leads the current. Now we will move on to a couple of example questions, so please feel free to pause the video and spend more time working them out.